The topic of this paper, comparing the Soldiers Cap and Kurridala groups in the eastern succession of the Mount Isa province with rocks of equivalent age in the Etheridge Province in the Georgetown inlier further east, was a spin-off of an extensive review of zircon isotopic data from the eastern succession. The review was prompted by the migration of data collected from Mount Isa since the 1980s by GA and GSQ into GA's Online Geochron Delivery System. Individual zircon analyses for samples were hitherto not readily available, and although many dates had been formally published, a significant number had not. Generation of detrital spectra of all samples from the eastern succession using isoplot was combined with the unmixing routine of Sambridge and Comston to determine maximum detrital ages and provenance components. Significant magmatic events that were potential sources of zircon in the sediments were also reviewed. The review was released last year in the Queensland Minerals and Energy Review Series. The magmatic events are summarised in this table. The volumetrically most significant are: in the basement areas, orthogneiss at 1870, Leichhardt volcanics at 1860 to 1865, and the Chalcedon and Ewan batholiths with ages of 1850 to 1860 million years. The Argilla Formation consists of felsic volcanic rocks around 1780 MA, but the Bolonga volcanics, originally mapped as Argilla Formation, are significantly younger at about 1760 MA. In the Wonga batholith, dates extend from 1780 and 1760 through to about 1740 million years, overlapping with the Birstall Gin Creek suites and equivalents, with ages in the range of 1735 to 1740 million years. Although the Peters Creek volcanics and related rocks and the Weber Fiery Creek igneous event occur in the far northwest of the Mount Isa inlier, populations of zircons of these ages are evident in eastern succession rocks. Their ages are about 1725 MA and 1710 respectively. The Sabella batholith, including the Carter's Bore rhyolite, have ages mostly falling between 1680 and 1670 million years. The Soldiers Cap group is a turbidite succession extending eastwards under cover. The lower units, the Llewellyn Creek Formation and the Mount Norna quartzite, and high-grade equivalents formerly assigned to the Gandry Dam gneiss, have similar maximum depositional ages and suggest that deposition began at 1685 or 1690 million years. The upper part of the Soldiers Cap group, the Till Creek volcanics, was probably deposited starting around 1655 to 1660 million years. In the Kurridala group, the turbiditic Starcross Formation has MDAs ranging from 1715 to 1670 million years, and the age of the upper Hampton Slate is constrained by a 1659 age of a dolerite sill that is in with error of the MDAs. For this presentation, data from multiple samples are pooled to allow easy comparison. For the lower units of the Soldiers Cap and Kurridala groups, both show large clusters younger than about 1900 million years, minor clusters around the Archean Proterozoic boundary, and almost nothing in the interval between. Full spectra for the Hampton Slate and Till Creek volcanics are superficially similar. Unmixing the clusters younger than 1900 million years shows that except for minor input from the Chalcedon-Leichhardt basement and Argilla Formation, the major sources were the Birstall Gin Creek Plutonic suites at 1740 and the Fiery Creek Weber event at 1710. The younger components that define the MDAs fall within the range of the Sabella Carter's Bore event, but may be slightly older in the Soldiers Cap group at 1685 compared with the Kurridala group at 1675. For the Hampton Slate, apart from the MDA being younger at 1655, other components are almost identical to those in the lower units. However, the one sandstone sample from the Till Creek volcanics, although having a similar MDA at 1658, is missing the Birstall Gin Creek and Fiery Creek Weber components. Various authors have long speculated that the Etheridge group and Inesley metamorphics at Georgetown correlate with the Soldiers Cap group in the eastern succession. Isotopic dates now support the correlation. The main constraints for the Inesley metamorphics are dates from simple detrital populations in leucogneisses that give ages of around 1705 million years, although as we'll see, most paragneisses in the unit are more complex. For the rest of the lower Etheridge group, the MDAs are mostly older, but there's one age of 1695 million years and the Deadhorse metabasalt has been dated at 1663. There's a leucogabbro sill in the upper part of the lower Etheridge group, but gives an age of 1656 million years, and that provides a minimum age for this part of the succession. The MDAs for the upper part of the Etheridge group, being all younger than this, are younger than 1655 million years. Both Soldiers Cap, Kurridala and Georgetown successions have iron-rich, low-K tholeiitic submarine basalts and dolerite sills with compositions approaching Morb, typical of those emplaced into passive margins undergoing rifting. This is a tectonic interpretation of Gibson et al., who also see the Etheridge group deposited on the same margin as the Soldiers Cap group, but as a distal turbidite succession. However, the zircon provenance patterns are strikingly different. The lower Etheridge group and most ionously metamorphic samples showing a large Archean component and a continuous spread of dates through the Paleoproterozoic, including peaks around 1900 to 2000 million years. Moreover, unmixing of the ages younger than 2100 million years reveals that important elements of the provenance of the Soldiers Cap and Kurridala groups, namely the Sabella Cartersbore and Birstall Gin Creek events, are missing entirely from the lower Etheridge group, and there are only a few grains of these ages in the ionously metamorphic samples. In addition, the distal turbidite interpretation has not been supported by other workers at Georgetown. Adam Nordsvan from Curtin regards the Bernica Creek Formation, at least, as shore face, with paleocurrents from the east. The inferred sandy and carbonate-rich protoliths of the ionously metamorphics in the east might also suggest that the shore lay in that direction. This, along with the dissimilarity in zircon profiles, was cited by Nordsvan et al. As evidence that the Georgetown rocks are exotic. Rather than having rifted away from Mount Isa, they were part of Laurentia until welded to the Australian craton during the assembly of Nuna. Zircons from the upper part of the Etheridge group have significantly diminished Archean to early Proterozoic zircon, and significant populations of zircons around 1650 million years, more like the Toole Creek volcanics. Lex Lambeck also showed that both sets of rocks have relatively primitive epsilon neodymium values compared with those from the lower part of the Etheridge and Soldiers Cap group. These data indicate a dramatic provenance change at around 1650 million years, suggesting perhaps that Georgetown had separated from Laurentia and it was then receiving sediment from the same source as the upper Soldiers Cap group. Potential 1650 million year sources from Mount Isa seem too evolved, and Lambeck speculated that juvenile magmatism, documented at 1655 million years in either the Mazatzal province in southern Laurentia or somewhere in Baltica, could be the source. An alternative juvenile source could have been the Benicia Arc, in a position between Laurentia and Australia, as suggested by Thorkelson and Lawton. Nordsvan et al., on the other hand, proposed a source in a hypothetical arc between the Australian craton and Laurentia prior to the amalgamation to form Nuna. An arc is a convenient way to explain the primitive neodymium values and young zircons once Georgetown was removed from Laurentia, although it must be pointed out that the upper Etheridge group and sediments in the Toole Creek volcanics must have been quite distal from the source. They are not obviously volcanoclastic, being mostly mud or silt. As mentioned, the contemporaneous volcanic rocks throughout the Soldiers Cap group and at Georgetown are low-K tholeiitic basalts, and are more consistent with models like that of George Gibson with a passive margin and Georgetown rifting away from Mount Isa. However, it might be possible to reconcile the models. Armit et al. Argued that Australia had amalgamated with Laurentia and was part of Nuna by about 1740 million years, and that following assembly, an interior ocean developed between Australia and Laurentia by 1710 million years. Therefore, as portrayed here, the Etheridge and Soldiers Cap successions may have formed on the passive margins on opposite sides of this new seaway. Consumption of the ocean along the Laurentian margin generated the Benicia Arc, whereas the Australian margin remained passive until the final amalgamation with Nuna and the onset of the Eisen orogeny. That said, I leave it to greater minds than mine to come up with an entirely robust model, consistent with all of the data, including the contrasting zircon patterns. Thank you.